So let's try to solve this problem. Determine the magnitude of the resultant force acting on the corbel and its direction theta measured counterclockwise from the x-axis. We are going to find the magnitude of the resultant force and its direction theta measured counterclockwise, or better still anticlockwise, from the x-axis. Now for this particular question, we have three forces, F1, F2, and then F3. And we are going to assume that all the forces acting towards the origin have negative magnitudes. So if we have a force acting away from the origin, that is going to have a positive magnitude. And then if the force is acting towards the origin, then it's going to have a negative magnitude. Now, since we have all the three forces acting towards the origin, we are going to assume each of them to have a negative magnitude. Now let's resolve each of the forces, F1, F2, F3, into their x and y components, and then we can add them up to find the resultant force. And then we move on to find the angle the resultant force makes with the positive x-axis, taking the anticlockwise direction. Also for this question, we have the units of the forces in pounds. However, for the sake of this video, we are going to consider all the forces in newtons. So for F1, because it's directed towards the origin, that's going to be negative 700 newtons. And the angle this force makes with the positive x-axis is 30 degrees. So we have theta equals 30 degrees. Now let's find F1x and then F1y. So for F1x, we have negative 700 cos 30, and that gives negative 606.22 newtons. For F1y, we have negative 700 sine 30, and that's also equal to negative 350 newtons. Also for F2, we have F2 equals negative 400 newtons, and the angle between F2 and the positive x-axis is 90 degrees. We have this angle to be 90 degrees. So we have F2x equals negative 400 cos 90. We know cos 90 is equal to 0, so this becomes 0 newtons. And then we have F2y equals negative 400 sine 90. Sine 90 is equal to 1, so 1 times negative 400, we have negative 400 newtons. Also for F3, we have the force to be negative 600 newtons. And this time we have a small slope triangle here. So let's draw the small slope triangle. So we have something like this. We have the hypotenuse to be 5. We have this side to be 4, and then this to be 3. F3 corresponds with 5. F3x corresponds with 3. And then F3y corresponds with 4. So at this point, we are going to find the values of F3x and then F3y. So for F3x, we know F3x corresponds with 3, and that is equal to F3, which also corresponds with 5, so F3 over 5. Notice that this force is acting in the second quadrant. Now in the second quadrant, we have the x value to be negative. So in that case, we are going to negate the force, F3. So that becomes F3x equals, we have negative 3 divided by 5 times F3. And then we have F3 to be negative 600 newtons. So times negative 600. And that gives 360 newtons. So that is the value of F3x. Now also for F3y, we have F3y also corresponds with 4. So F3y divided by 4 equals F3 divided by 5. Now at this point, you realize that the y component is going to be positive. So we have F3y equals 4 over 5 times F3. F3 is negative 600. So that is equal to negative 480 newtons. At this point, we have the x and y components of each of the forces. So we are going to add them up. So for Fx, we have Fx equals F1x plus F2x plus F3x. So we have Fx equals negative 606.22 plus 0 plus 360, and that gives negative 246.22 newtons. So this is the value for Fx. Also for Fy, we have F1y plus F2y plus F3y. F1y is negative 350. We have F2y negative 400, and then F3y negative 480. That also results to negative 1230 newtons. So negative 1230 newtons for Fy. At this point, we are going to find the resultant force. So the resultant force F is equal to the square root of Fx square plus Fy square. So we have Fx to be negative 246.22. So we have the square of it plus negative 1230 square. Therefore, we have F, which is the resultant force, to be 1254.40 newtons. So this is the magnitude of the resultant force. Now let's find the angle the resultant force makes with the positive x-axis. Now looking at the component forces for the resultant force, which are Fx and then Fy, you realize that we have negative values. So this is going to be the position of the resultant force. It is going to act in the third quadrant. Now in the third quadrant, we have this to be the negative y-axis and then this to be the negative x-axis. And since we have negative values for both the x component and the y component, this is going to be the position of the resultant force. So in order to find the angle the resultant force F makes with the positive x-axis, we first of all need to find the angle alpha formed between the negative x-axis and the resultant force, and then we can add 180 to it in order to find the value the resultant force makes with the positive x-axis. So at this point, let's find the value of the angle alpha. So to find the value of the angle alpha, we have alpha equals tan inverse of the absolute value of the y component divided by the x component. So that is equal to tan inverse of, we have Fy to be 1230 divided by Fx 246.22. Therefore, we have alpha to be equal to 78.68 degrees. So this is the value of the angle alpha. Next, we are going to add 180 to it, because from this point through to this point is 180. So we need to add 180 to the angle alpha. Therefore, we have theta to be equal to 180 plus 78 0.68, and then theta is equal to 258.68 degrees. So we have the magnitude of F to be 1254.40 newtons, and we have the angle F mixed with the positive x-axis to be 258.68 degrees. Now let's move on to the next question. Now to this question, if the resultant force acting on the bracket is to be 750 newtons directed along the positive x-axis, determine the magnitude of F and its direction theta. So we are told that if we have a resultant force, or the resultant of these three forces acting on the bracket is to be directed along the positive x-axis, so we have this to be the resultant force Fr, which is equal to 750 newtons, that is directed along the positive x-axis. So that is what we've done. Determine the magnitude of F and then its direction theta. Now let's resolve Fr into its x and y components. So since we have Fr to be equal to 750 newtons, and the angle between Fr and the positive x-axis is 0 degrees because we have it lying on the positive x-axis. Now to resolve this into its x and y components, we have Frx equals 750 cos 0 degrees. We know cos 0 degrees is equal to 1. So 1 times 750 is 750. So we have this to be 750 newtons. And then we have Fry equals 750 sine 0, and that is equal to 0 newtons. Now at this point, we are going to resolve each of the forces into their x and y components, and then we can add them up and then equate to the x and y components of the resultant force. So we have this to be F. Let's call this F1, and then this F2. So for F, we don't know the value of F. That's what we are looking for. And then we don't know the angle F mixed with the positive x-axis. But for F1, we have F1 to be 600 newtons. And then for the angle F1 mixed with the positive x-axis, let's draw the negative y-axis. Now if this angle is 45 degrees, then it also means that we have this angle to be 45 degrees. So starting from the positive x-axis, moving in the anticlockwise direction to meet the force, we have from the positive x-axis to this point is 90, through to this point is 180, through to this point is 270 plus 45, and that is 315 degrees. So we have theta to be equal to 315 degrees. Therefore, F1x is equal to 600 cos 315, and that is equal to 424.26 newtons. And then for F1y, we have 600 sine 315, and that is also equal to negative 424.26 newtons. Now for F2, we have 325 newtons, and then we are given a small slope triangle, that is the 5, 12, 13 triangle. So we have this side to be 5, this to be 12, and then this to be 13. So 13 corresponds with F2, which is 325 newtons. F2y corresponds with 12, and then F2x corresponds with 5. Now let's find the values of F2x and then F2y. Now, because this force, that is F2, acts in the first quadrant, we have both the x and y components to have positive magnitudes. So we have F2x divided by 5 equals F2 divided by 13. So F2x is equal to 5 divided by 13 times F2, which is 325 newtons. Therefore, we have F2x to be equal to 125 newtons. Now let's find the value of F2y. So for F2y, we have F2y divided by 12 equals F2 divided by 13. So F2y equals 12 divided by 13 times 325 newtons, and that is equal to 300 newtons. So that is the value of F2y. Now, since we have the values of the x and y components of the three forces, let's add them up so that we can equate it to the x and y components of the resultant force. So for this force F, we have this to be Fx plus Fy. These are the x and y components. So let's add them up. So we have Fx plus F1x plus F2x equals Frx. So let's find the value of Fx by substituting in the values of F1x, F2x, and then Frx. So we have Fx plus F1x is 424.26 plus F2x, we have 125 equals Frx, we have 750. So we have Fx to be equal to, now let's sum these two values up and then transpose to the right hand side. So that becomes negative 549.26, and then that is equal to 200.74 newtons. So this is the value of Fx. Now let's do same for Fy. So we have Fy plus F1y plus F2y equals Fry. So F1y is negative 424.26. So that becomes negative 424.26 plus, we have F2y to be 300. So plus 300 equals Fry is 0 newtons. So equals 0. Now let's add these two up and then transpose to the right hand side. So we have Fy equals, now this becomes negative 124.26. So we transpose to the right hand side, we have 124.26 newtons. So this happens to be the value or the magnitude of Fy. Now since we have the values of Fx and then Fy, we can find the magnitude of the force F. So we have F equals the square root of the x component square plus the y component square. So we have the x component to be 200.74. So we have the square of it plus 124.26, also the square of it, and then we have the magnitude of the force F to be 236.09 newtons. So this is the magnitude of the force F. Now let's find the angle the force makes with the positive x-axis. Now since we have positive values for Fx and then Fy, it primarily means that the force occurs in the first quadrant, and it is evident here we have the force occurring in the first quadrant. Now we are going to find the angle theta formed between F and the positive x-axis, taking the anticlockwise direction. So to find the value of the angle theta, we have theta equals tan inverse of the absolute value of the y component, which is 124.26, divided by the absolute value of fx, that is 200.74. Therefore, tan inverse of this value gives 31.76 degrees. Therefore, the angle the force F makes with the positive x-axis, taking the anticlockwise direction, is 31.76 degrees.